rate in, rate out. This video will cover a specific application problem that is related to integration. You'll be given some information that expresses the rate at which something enters and the rate at which something leaves. How that is expressed could be through a function, so a rate in or rate out function, or maybe you have a table of values. But either way, the connection to integration is that integration will calculate accumulation. We know that the integral is the act of adding together the sum of the areas of those little rectangles when we first introduced the integral. So the idea behind accumulation should make sense due to the fact that integration is a summation. So what types of questions are we going to be seeing with a rate in, rate out problem, and how do we handle that? So the first thing we might be asked is, can we calculate the amount of whatever we're dealing with that went in or that went out over some time period? If we want the amount in or the amount out, to calculate that, all we have to do is integrate the rate in or the rate out function to determine the accumulation over that time period from, say, A to B. So if we want amount in, we're going to integrate from A to B, so it'll give you some time period to determine how much went in, and we're going to integrate that rate in function. If we want the amount out, we're going to want to integrate that rate out function. So that's the first thing we want to be able to calculate. The total amount that went in or the total amount that has been removed over some time period, and it is as simple as integrating that rate in or that rate out. So that rate in represents the rate of change of that object over some time period, and the rate out, the rate of change. So if we integrate, we get that accumulation, that total amount. The second thing we want to be able to do is determine whether the total amount at some time is increasing or decreasing, or maybe we want to calculate along what interval is the amount increasing or decreasing. Either way, this requires a comparison. So what we want to do is compare the rate in and the rate out. All we have to do is, for something that's increasing, so think of this intuitively, if the rate in is greater than the rate out at some time or along some interval, then the amount should be increasing. With that same logic, to determine when the amount is decreasing, we would look to see, is the rate out greater than the rate in at that time or along some interval? So don't overcomplicate this question either. If they ask you, is the amount increasing or decreasing at a specific time, all you have to do is evaluate the rate in and the rate out functions at that time, and then compare, is the rate in greater or less than the rate out? And that will give you your answer. If you want to determine along some interval where something is increasing or decreasing, you'll have to usually compare the graphs. So these are oftentimes associated with calculators. And if we graph the rate in and the rate out function, we're just looking, okay, what interval is the rate in above the rate out or the rate out above the rate in? And that will dictate whether or not something is increasing or decreasing. And we can find the interval. If there's multiple intersection points, we can calculate the intersections with the calculator as well. But this is just the general idea. We can look at a specific example at the end of the video. But we just want to cover concepts for now. So that's the second one. The third one is going to involve you being able to express the total amount of this thing that is present at some time period, okay, or at some moment in time. And a branch off of that is it might ask you, what is the maximum amount or what is the minimum amount of this thing that is achieved along some time interval? So either way, whether or not it just asks you to express the total amount at some point, or if it asks you to actually calculate a min or a max amount, you still need to be able to represent the total amount at any time. So how do we represent total amount in a rate in, rate out problem? It will give you an initial amount. So to get the total, what we're going to do is say the initial amount. So what are we starting with? And then we're going to add the amount that went in. Now, what do we integrate from? Your starting time to whatever time they're asking you to find the total at. So the total, we'll say at time, we'll say t.
Good morning, part of the central.
So this is for a total at some time t, and we'll say t sub 0 is our starting time. So we're going to say initial amount, what did we start with, plus the total amount that went in from when we started to where we want to determine the total amount at. So we're going to integrate the rate in, because again, that will accumulate how much is entered. And then we're going to subtract from that the rate that's left over the same time period. Or I should say, in most cases, it's the same time period, but you may want to pay attention to the context of the problem. But in general, this is the idea. Initial plus amount in plus minus amount out will get you the total at that time. Now, if the next part of the question asks you, well, when does it reach a max or a min over some time interval? Well, now you have an equation that represents the total amount. So if you want to know when it's maximized or when it's minimized, you're going to take the derivative. You're going to analyze the derivative. When is the derivative equal to 0? So max min, we want to take derivative we'll call it the total function. Determine the critical points. And don't forget to include your endpoints, because often these are closed intervals. Then sign chart. And then analyze your sign chart to determine where the max or min occurs. Now, I'll often ask you, what is the max or min amount? So if it asks you, when does the max or min occur? We know that we can get our answer by just looking at that t value in the sign chart from the critical points. But if it asks you what the max or min, so this will be when the max or min happens. How do we get what is the max min? We'll have to evaluate the total function at the potential candidates. So maybe you have more than one max min location. You're going to have to evaluate and compare. And that will get you the total amount, or the maximum total, or the minimum total over some time interval. So don't forget those endpoints. Make sure you check those. But remember, max or min, how do we optimize a function? So optimization, we're going to take the derivative of that thing we're trying to find a max or min for. So don't forget those concepts that we discussed in the derivatives chapter. because that will be integrated within these questions that you'll see. So everything's fair game, all within one question. So understanding how to represent a total amount by doing initial plus the total that went in minus the total that went out. Then take the derivative for the max min, make a sign chart that will tell you when the max or min happens. Maybe there's more than one. If there is more than one, or even if there's only one, if it asks you what is the max or min total, you'll have to evaluate the actual function at that point in time to determine the amount. Now, when it comes to differentiating the total, what happens is the derivative of the total when you take the derivative of the constant initial amount, it goes to 0. When you differentiate the rate in integral, you'll notice that we have to use the fundamental theorem to get that derivative, which the bottom is oftentimes some constant, some starting time value. The upper bound is going to be the variable. So when you differentiate it, you just get the rate in function at t. So this is often what you get when you take the derivative of that total function. And you want to know when does this equal 0 to find your critical points. So if you're still unsure what I mean, when you take the derivative of this piece or this piece, okay, these are going to be constants. And you should have a variable to represent, that's your input variable to the total function, right? So your input variable is going to be your upper bound on the integral. And when you differentiate, remember we just plug in and then multiply by the derivative of the upper bound, which in this case is going to be 1. So you just have your rate in function minus your rate out function. So there's your derivative, set it equal to 0, and solve from there. So that's the general concept, the idea behind these rate in, rate outs, and the types of things that you'll be asked to do. So can you get the amount that went in or the amount that went out over some time? Can you determine if the amount is increasing or decreasing at a specific time? Or can you determine when the thing would be increasing or decreasing over some interval? And then lastly, can you represent the total amount at some time? And then can you figure out when it's maximized or minimized along the interval? So having said all that, let's look at an actual question. So this AP question is calculator involved, so I'm not going to make the actual computations, but we'll talk about how to set things up and what you should look to do to actually get the answer. So the rate at which rainwater flows into a drain pipe is modeled by the function R. So this is our rate in function. So let's make a note of that. T is measured in hours, and it's ranging from 0 to 8. So we have some closed interval, so that may become important later on. The pipe is partially blocked, allowing water to drain out the other end of the pipe by D of T. So draining out. So D of T is our rate out. So we might want to take note of that. Still going from 0 to 8. So the rate at which it goes in and the rate at which it goes out is over the same time period. Now there are some problems where the rate out might not start until like say 3. Okay, so you want to pay attention to the time intervals. Don't skip over that. There are 30 cubic feet of water in the pipe at time t equals 0. So 30 is our initial. So A, how many cubic feet of rainwater flow into the pipe during the 8-hour time interval? So we want to know how much is going in. So a total amount, how many cubic feet? So that's asking for an accumulation of the water that's going in. So to do that, we're going to integrate the rate in function. So to determine this, we're just going to say the integral from 0 to 8 of R of t dt. That will get us how much has flowed into the pipe over the course of this time. That's all it is. All we know to know is how much went in. Now, this is a calculator question. So what we would have to do is actually plug this in, this 20 sine t squared 35. And we can let the calculator make that computation for us. If this was a non-calculator question and we were faced with an easier integral to compute, Then antiderivative of the integral evaluated at the upper bound minus the lower bound. So it's just using fundamental theorem with antiderivatives to evaluate that integral. But that's how you would do part A. Let's look at part B. Is the amount of water in the pipe increasing or decreasing at time t equals 3? Give a reason for your answer. All right, so is it increasing or decreasing? Well, and this is at a specific time, so we don't need to look over some interval. So at 3, so here's what we're going to do. Well, what's the rate that it's going in at time t equals 3? And what's the rate at which it's going out at time t equals 3? And then we want to make a comparison between these two. If r of 3, whatever that value is greater than d of 3, then we'd say it's increasing. If r of 3 is less than d of 3, then we would say it's decreasing. So that's your analysis, and there's your reason. So when it comes to the reason, so you want to actually compute r of 3, compute d of 3, and then say, because r of 3 is greater than d of 3, whatever those values are, the rate at which it goes in is greater than the rate at which it goes out, and therefore the amount is increasing. Or you might say the rate at which it goes in is less than the rate at which it goes out, and therefore the amount is decreasing. So when it comes to your reason, give a written explanation, make sure you show the math as well. At what time t is the amount of water in the pipe at a minimum? Justify your answer. Okay, so to get the minimum, we need to be able to express the amount of water at any time. And then we're going to minimize the function that we need to find the minimum for. That represents the total amount. So total amount, again, is going to be equal to the initial amount, which is 30, plus the integral of the rate or the total amount that went in from 0 to 8. So again, pay attention to the time. We're going from 0 to 8 rate in, which is r of t. Then we're going to subtract from it the amount that went out. So actually, let's change this. We want to know when this thing's going to reach. So let's represent. This is the function that will get us the total at any time t from 0 to 8. So I should have done that instead. Okay, if I plugged in 8 for t, that would get me the total amount at 8. Okay, so a couple things to note. Initial amount is 30. 0, this is when it starts. This is when the rate in starts. And then we're going to some time that we don't know yet. We want to know when it's going to reach a minimum. So that's our variable what this problem deals with. We have dummy variables that don't match the variable for the function. So the x's don't match the t's. Now, this one also starts at 0 because at 0, that's when the rate out occurs. So if the rate out started at 3, well, we would want to put a 3 there. Okay? So when does the rate in and the rate out start? That's what the lower bounds of your integrals are going to be. From here, we now have a function that represents the total amount at any time t. If we take the derivative with respect to time, we're going to get r of t minus d of t. So 30 goes to 0. Fundamental theorem, just plug in and then multiply the derivative of what you're plugging in. Now in this question, to find the minimum, we want to know when this equals 0. How are we going to determine when that equals 0 with those complicated functions? We're going to use our calculator. So in our calculator, we're going to graph this. And we're going to find when it equals 0. So we're going to look for, so graph and look for x-intercepts. Now we only want x-intercepts in this range from 0 to 8. Okay, those are your critical points. So you set up your sign chart. Make sure we include our endpoint, 0, 8, and then we're going to have some points in between, wherever those are. Okay? Make the sign chart accordingly. Wherever that is, let's just pick some random value c. Let's say it goes plus to minus. Okay? And then maybe there's one more. So it's going up from 0. So this is a min. This is going to be a max. Min. Max. So we have two candidates for the minimums at 0 and at D, whatever D was. So again, I'm just making this up. I don't know what the actual numbers are, but I'm just telling you how to approach this. Then that's when the minimum occurs. So we have a minimum at 0 and we have a minimum at time D. How do we figure out? Oh, so it just says at what time. Okay, so maybe there's only one value. If it says what is the amount of water or what is the minimum amount, then we would actually have to plug in these times into our function to make that computation. So we would do 30 plus 0. Let's say the D value was like 3. So we say the min happens at 3. We would plug in 3. We would let our calculator make this computation. We could plug in this whole thing to our calculator, spit out an answer, and there's our min value. But that's how you evaluate the critical points. You're going to take the derivative of the total function. How do we get the total? Initial plus amount in minus amount out. Take the derivative. You end up just getting rate in minus rate out. Set that equal to 0. Find the critical point. So this is a non-calculator question. You're still doing the same thing. Set it equal to 0. Find the critical points. Don't forget to include those endpoints and analyze those when you're making your final analysis. If you have to determine what is the minimum or maximum, take those into consideration. In this case, it just says at what time does the minimum happen. And for your justification, just explain that at time t equals 3, the derivative went from negative to positive, indicating a minimum occurred at that time. That's how you handle that. Then the last question, the pipe can hold 50 cubic feet of water before overflowing. Water continues to flow in and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. So begin to overflow when the total amount equals 50. So we already have a representation for the total. We take the initial plus, now it says at time w for when this is going to happen. So let's go from 0 to w of r of t dt minus from 0 to w the rate at which it goes out. And we want to know when does this equal 50. So we just have to write but do not solve. So that's it. So when does the total equal 50? And we're going to use that w variable for the variable in our function. Okay, again, the t variables in this case are our dummy variables when we want to know when does that equal 50, and there is when it would start to overflow. So that's an example of a rate in, rate out problem with some conceptual overview of how to handle these situations.